All right. So let's talk briefly about the different parts of the brain. If you want to divide the brain, you could divide the brain in many different ways, but the general divisions are hindbrain, midbrain, forebrain. The hindbrain includes the cerebellum, pons, and medulla. The midbrain includes several structures, but importantly, the superior and inferior colliculi. And then the forebrain is pretty much everything else, right? Outside. But we'll talk about the thalamus as part of the brainstem. So the hindbrain, from a developmental point of view, the hindbrain is the first to develop. It is absolutely essential for survival. And there are some people who argue from an evolutionary perspective, the hindbrain was the first to evolve. Now, the three structures of the hindbrain include the medulla, pons, and cerebellum. What does the medulla do? Now, I said to you in the previous lecture that the medulla is directly connected to the spinal cord. There's no arbitrary or no clear division. This is where the spinal cord ends, and this is where the medulla begins. It's a fairly arbitrary distinction. But the medulla is responsible for vital functioning. So things like breathing, right, heartbeat, and digestion. It is possible for a person, if they had damage above the medulla, to function, right? Now, the person would likely remain in a vegetative state. So let's say we removed everything but the medulla. That person, in principle, could survive. Not very well, but they need the medulla for vital function. If there's damage to the medulla, survival is highly unlikely. Now, the pons is above the medulla, and it has a series of fiber tracts that go up and down from the spinal cord to the brain and vice versa. The pons also has a part of it called the reticular formation, or the ascending reticular activating system, if you want the technical term. And the reticular formation is responsible for attention, alertness, and arousal. So we say the pons is linked to attention, alertness, arousal. Interestingly, the pons is also implicated in ADHD, right? Because the reticular formation serves as a filter of important versus extraneous information. And if it doesn't work properly, it's going to interfere with your ability to concentrate. The cerebellum is typically responsible for balance, posture, voluntary motor movements. We talked about the cerebellum briefly when we talked about GABA and the impact of alcohol and GABA neurons in the cerebellum, and it could impact your ability to walk a straight line. But the cerebellum also is linked to other voluntary movements. It could result in clumsiness, slurred speech, balance problems, etc. And these are your three pieces of the hindbrain. Now, if you look at the cerebellum under like a brain image, it looks as if it's its own second brain. It's like this on the back of the brain. It's wrinkly. It looks like its own brain, but it's not its own brain. It's actually part of the hindbrain. The midbrain. The midbrain is now linked to some sensory motor functioning and reflexes that promote survival. So the two that I'm going to focus on are the inferior and superior colliculi. If I were to do a side profile of my face, and I were to ask you what's higher, my eyes or my ears, you would say what?
Your eyes. Ear.
Eyes, right? My eyes are above my ears, generally speaking. So if we were to think of the superior and inferior colliculi, Superior in biology means above. It doesn't mean better than, it just means above. Inferior in positionality means below. So if using what I just said, the superior colliculi is linked to the visual system, and the inferior colliculi is linked to the auditory system, right? So reflexive responses to a balloon popping, let's say, a startle response, well, that's oftentimes activating the inferior colliculi. Now let's talk about the thalamus. The thalamus sits on top of the brainstem. And the best way to describe the thalamus is a relay station. And what's interesting about the thalamus is it receives input from and output from all senses except for smell. So the best way I like to say it is it's similar to Grand Central Station. You can go from Grand Central Station to anywhere in the country, and you could get to Grand Central Station from anywhere in the country if you wish. So the thalamus plays a vital role of communicating between brain areas. So I'm not going to overly belabor the point, but I'm talking to you as the thalamus as a whole, but we could further subdivide the thalamus into 10 separate nuclei. And for example, in vision, the lateral geniculate nucleus, which is one part of the thalamus, is important. And for hearing, the medial geniculate nucleus is important. The one part or one sense that doesn't rely on the thalamus is smell or olfaction. There's the olfactory nerve that has a direct communication between the brain and olfactory sense, does not rely on the thalamus. Ask me why, I will tell you, God or evolution, I don't know. Right? Now, put it all together. All of the structures from the medulla up to the thalamus we refer to as the brain stem. And as I said, the brain stem, and in particular, the reticular formation, which is the band of fiber tracts that go through it, are responsible for attention, alertness, arousal. Now, if you could take a look at this picture and see how the brainstem works. So I'm going to move my cursor again. And here we're looking at the medulla. The medulla is the base of the brain. And below the medulla is the spinal cord, right? Remember when I said the spinal cord leads directly into the medulla, right? There's no major dividing mark. Now, this over here is the pons. You might hear this referred to as brachium pontis because it looks like there's a band or like a waistband or cummerbund around the pons. Then we have the midbrain and then the thalamus. But notice you have this band of fiber tracts, which I refer to as the reticular formation, that travels through all of the brainstem. Attention, alertness, arousal. This reticular formation is absolutely crucial in your ability to focus, in your ability to sift out extraneous information. But I said outside of the brainstem, everything else is still happening. So if you were to look on the picture on the left, we superimposed the brainstem as like a carve out, right? But look, there's a whole lot of brain region outside of it. Now, I mentioned the cerebellum, right? Look at the cerebellum back here. I said it looks like it's a second brain, its own brain, but it's not. So this is called the cerebrum, and this is called the cerebellum. We'll talk more about brain structures above the thalamus. We'll talk about the limbic system, cortical structures in our next series of lectures. But this seems like a good place to stop. So let me stop here.